Hello. Good evening, everyone. This is the fourth live session on the course Microelectronics Devices to Circuit. I am Anjali Goyal, the TA of this course, and along with the course tutor, Professor Sudeep Das Gupta. Before starting, I would like to tell that in case there is low internet connectivity, or in case if I somehow just drop out from this live session, so kindly wait for 10 to 15 minutes to resume the session again, and I hope that this becomes an interactive session. So the first question, so in this week the MOS transistor was discussed, so we'll be discussing questions on that only. So from the figure, determine the value of RD and RS, so that the transistor operates at ID equals to zero point 0.4 milliamperes and VD equals to plus zero point 0.5 volt. The NMOS transistor has VT equals to zero point 0.7 volt, mu Cox is equals to 100 new ampere per volt square. Length is 1 micrometer and the width is 32 micrometer. Neglect the channel length modulation, that is lambda equals to 0. So I'll draw the circuit. So I'll give you a couple of minutes and then we can start with the discussion.
Ma'am, RD is 1.25 kilo ohms.
RD is
1.25 kilo ohms.
no, it is not 1.25 kilo ohm.
Okay, ma'am.
Yeah, this 5 kilo.
Can you repeat? Surajit?
Yeah, it's 5 kilo RD.
Yeah, it is 5 kilo ohm.
RS is 5.75 kilo.
No. Okay, we'll discuss now. Okay, so for RD, it is VDD minus VT divided by ID, which is equals to 2.5 minus 0.5, and this is zero point 0.4 milliamperes. This gives as 5 kilo ohms. Okay, so for now, to determine RS, so what is the value of source, voltage at source?
Minus 2.5.
0.4 RS minus 2.5.
Minus, what is the value of RS? Sorry, VS?
0.4 RS minus 2.5 volt.
No. So first we'll take the equation of drain current. Okay. So zero point 0.4 milliamperes mu and Cox is given. W by L, I think I have given. Yeah. So now your V overdrive after calculation will be 0.5 volt. So now VGS minus VT is your V overdrive, which is VGS is equals to V overdrive plus VT.
But ma'am, how can we know it is in saturation? It could be in linear also, no?
No, but it is
Means
mentioned.
without
No,
calculating.
no, because it is written that you have to ignore the channel length modulation, and channel length modulation is only present in saturation condition.
No, but even if it is, we can consider saturation. And then also, like lambda equal to zero, we can consider. No.
Yeah, so that is why it was. Otherwise, it would be had been 1 plus lambda VDS. So this is 0. So this becomes your entire equation. However, there is no significance of channel length modulation in the linear region.
Yeah, but sometimes they are also given like lambda equal to zero, but we are considering the device is in saturation. But that case, I am considering without calculating the VDS, how can we know the region directly? Means that is the I'm saying.
So you have considered the region of saturation, right?
Yeah, it could be linear also. Means without finding the VDS, I cannot assure. Like lambda equal to zero, that logic is fine. But sometimes it is also like happen ki lambda equal to zero, but we are still operating in like
No,
non-linear region.
but for that first you need to check that is it in saturation or not. If the situation comes that it is not in saturation, then we assume that it is in linear. But the first test will always be when it is given the channel and the modulation, and if it is not mentioned that it is in the linear region, we all by default operate it in the saturation region.
Means most of the time we are taking that thing only, no?
Yeah, saturation region.
Okay.
So VGS is equals to zero point 0.5 plus zero point 0.7, 1.2 volt. So now since we know that Vg is 0, so Vs is minus 1.2 volt. So now Rs is equals to minus 1.2 volt minus 2.5 0.4. So this will give out to be 3.25 kilo ohms. So if anyone has any doubt, can please ask. Okay. Figure shows
Can you show me the last slide once, please? Okay, for this case, why you can like it could be minus zero point 0.5 also now, like V overdrive voltage. Is that any neglecting the negative part or?
we yeah, the overdrive voltage will always, for n type it will be only positive. It is always, this is your n type graph, right? In that we always take VGS and your VT always positive.
Oh,
That,
okay, okay, yes, okay, okay.
yeah. So this has to be taken as positive.
Yeah, okay, okay.
Okay. Connected together. So you have to find an IV relationship of the resulting two-terminal device in terms of MOSFET parameters. Kn is equals to Kn dash W by L, and Vtn, neglect channel length modulation. So yeah, so you have to find an IV relationship. This is a very simple one.
I equal to Kn into V minus Vt whole square.
Divide by 2.
K by 2 actually. Kn by 2.
Yeah. So this is just an equation of saturation.
Yeah.
So since your Vd is equals to Vg, so Id is equals to half Kn dash W by L Vgs minus Vtn whole square. So this can be written as, okay, I is equals to half Kn dash W by L V minus Vtn whole square. So half Kn V minus Vtn whole square. So does anyone has any doubt in this? Okay.
Ma'am,
Yes, Sanjay.
I have a doubt which is related from assignment number 3. Ma'am, question number is 8.
We cannot discuss the questions of assignment.
Okay, ma'am.
Okay, so your Vd is 0.1 volt. So you have to find what is the effective resistance between drain and source when Vd is made at plus zero point 0.1 volt. Let Vtn is equals to 1 volt and Kn dash W by L half Ma V square. So the diagram is, Okay, so I'll give you a couple of minutes.
Is that kn dash part include that 1 by 2 factor or what?
Yeah, it includes the Kn dash W by L whole is 1 by 2. Your mu and Cox is included in this.
It is 0.5k.
No, no. In which region have you considered, Surajit?
But
Yeah, Saurabh. Okay, Surajit, you can tell which region you have considered.
Like linear region.
Yeah, yeah, it is. It will be in linear region. Yes, Saurabh.
no, ma'am, I was telling that only it will be in the linear region of operation.
Okay.
So that VDS square by 2 that part I can neglect, na?
No, you cannot neglect. You have to incorporate.
Okay. That's why it's changed. 512.82 ohm.
12 point.
82 ohm.
No. The the
5.82.
the decimal part you need to check.
Okay.
Ma'am, is the ID value coming as 0.1975 milliampere?
No, it is 0.395.
Okay.
Okay, so what is the gate voltage? VGS.
5 volts, ma'am.
Okay,
So the overdrive voltage will be 4 volt VGS minus VT.
yeah. So
And
ID is equals to mu n C ox W by L VGS minus VT VDS minus half VDS square. Does everyone agree with this?
yes, ma'am, it is correct.
Okay, so now this is your Kn dash W by L. So this becomes half VGS minus VT is 4. Your VD is 0.1 minus half into 0.01. So this gives 0.395 milliamperes. So now your RD is equals to VDD minus VD by ID. So your VDD is 5 minus 0.1 divided by 0.395 is equals to 12.4 kilo ohms. So does anyone has any doubt in this? Okay. Uh, from the figure, determine the voltages at all nodes and current through all branches. Let Vt is equals to 1 volt and Kn dash W by L is equals to 1 milliampere per volt square. Assume Okay, so I'll give it some time.
Ma'am, gate resistance is 10 mega ohm.
Yeah, it is 10 mega ohm.
ID is 0.5 milliampere.
Yeah, it is 0.5 milliampere.
VS is 3 volt and VD is 7 volt and VG 5 volt.
VG, sorry, can you please repeat?
VG 5 volt, VD is 7 volt and VS 3 volt.
Yeah. c- Uh, so I'll wait another 2 to 3 minutes so that others can practice, and then I'll discuss the solution. Okay, so we'll start. So using the voltage divider, your VG is equals to VDD RG2 RG1 plus RG2. This is equals to 10 into 10 divided by 20, so plus 5 volt. Now VGS is equals to 5 minus 6 ID. So ID is equals to half 1 into 5 minus 6 ID minus 1 whole square. So this gives us a quadratic equation. So can someone tell me what are the two values of ID?
0.5 milliamp and 0.88 milliamp.
Yeah, and point, okay, so I calculated 0.89. So when we use this, our source voltage came out to be 5 5.34 volt, which is much greater than your Vg, which is not possible. So we selected 0.5 milliamperes. So now your ID is equals to 0.5 milliamperes, Vg is equals to 5 volt. After replacing your Vs is equals to 3 volt, and your Vd is equals to 10 minus 6 into 0.5. This is Rd Id. So this equals to 7 volt. So does anyone has any doubt in this? Okay. Uh, the transistor operates in saturation with ID equals to 0.5 milliamperes and Vd equals to plus 3 volt. Let the PMOS transistor have VTP equals to minus 1 volt and Kp dash W by L is equals to 1 milliampere per volt square. Assume lambda equals to 0. Find Rd. Okay, so I'll wait for a couple of minutes.
6 kilo ohm RD equal to
Yeah,
Yes, 6 kilo ohm is coming.
yeah, 6 kilo ohms. Okay, so I'll wait for others for 1 to 2 minutes and then I'll solve. Okay, so ID equals to half Kp dash W by L V overdrive square. So after replacing V overdrive is equals to 1 volt, VSG is equals to VTP plus V overdrive is equals to 2 volt. So now you have to calculate the values of RG1 and RG2. So it could be 2 mega ohm since it is in the ratio of 2:3. So I took the basic, and now your RD is equals to VD by ID, which is equals to 6 kilo ohm. Okay, so now moving on to the next question. The NMOS and PMOS transistors shown in figure are matched with Kn dash Wn by Ln is equals to Kp dash Wp Lp equals to 1 milliampere per volt square, and Vtn is equals to minus Vtp equals to 1 volt. Assume lambda to be 0. Find IDP and IDN as well as Vout for Vi is equals to 0 volt plus 2.5 volt minus 2.5 volt. So the circuit is Yeah. So I'll give you some time.
For Vi equal to 2.5 volt, uh, NMOS will be in linear and PMOS will be in cutoff.
For VN,
Vi equal to 2.5 volt.
I'll check and I'll. Can you repeat?
PMOS is cutoff and NMOS in linear.
Yeah.
Okay.
PMOS is cut off.
And for Vi equal to 0 volt, output also 0 volt.
Yeah.
Okay. For Vi equal to 0 volt, both transistor will be in saturation and current will be 1.125 milliamps.
Yeah.
Ma'am, IDN is coming as 8 milliampere.
For
With the VIS, I'm considering the VIS 2.5 volts.
VI as 2.5 volt. So what is your IDN?
8 milliampere is coming.
No.
Is it 0.24 milliamps approximately?
Yeah.
Okay.
For Vi equal to minus 2.5 volt, ID is same as 0.243 million.
For VI is equals to,
Minus 2.5 volt.
yeah, it is same, IDP.
Yeah.
Okay, so when Vi is equals to 0 volt, since this is symmetrical and have same VGS, so your V out will be 0 volt. So IDN is equals to IDP, and it is in saturation, is equals to half into mu n Cox W by L, which is given as Kn dash W by L, which is 1. Then we have 2.5 minus 1 whole square equals to 1.125 milliamperes. So this is for your Vi equals to 0 volt. Now when Vi equals to minus 2.5 volt, oh sorry, plus 2.5 volt, so your QP will be in cutoff and Qn will be in triode, or as we say in linear region. So your IDN Kn dash so replacing the values, uh, due to internet maybe the screen is getting, so your IDN, so solving these two equations, that is this one and this one, your IDN equals to 0.244 milliamperes, while V out is equals to minus 2.44 volt. Now the same output will be observed when your Vi is equals to minus 2.5 volt. In this IDP equals to 0.244 milliamperes and V out is equals to 2.44 volt, and your Qn will be in cutoff and QP will be in triode region. So if anyone has any doubt,
Ma'am, can you just go to the previous slide? Okay, thank you, ma'am.
okay. So moving on to the next question. If VDD equals to 3 volt VTN is equals to 0.5 volt and VTP is equals to 0.4 volt. Uh, so you have to tell me different case. I'll first draw the circuit. Okay, so this is V naught, Vi2. Okay, so in the first case, if Vi1 equals to 0.2 volt and Vi2 is equals to 3 volt, so you have to tell me what is V out.
V naught is 3.4 volt.
No, no Kavya, it's not zero.
VG2 is zero point 0.2 volt, right? VG2.
No, VG2 is 0.2
zero
volt.
point 0.2 volt.
Yeah,
Yeah, then PMOS will be on and V naught will be, oh, V naught will be, sorry, 2.6 volt.
no, V naught will be exactly what is the input Vi2.
It will be 1 VT down, no? If it is on.
No, but it is greater than your VTP, so that is why. Okay, so Vg1 minus Vi1 is equals to 2.8 volt, correct?
Yes, it is 2.8.
So this is greater than Vtn.
Greater than 15.
So your Vg2 is equals to Vi1 is equals to 0.2 volt. Now Vi2 minus Vg2 is also equals to 2.8 volt, which is greater than Vtp. So your V0 is equals to 3 volt. Okay, so the B part, when Vi1 is equals to 1 volt and Vi2 is equals to 2 volt.
Ma'am, VG2 is 1 volt.
Yeah, Vg2 is 1 volt.
Ma'am, V out is 2 volt.
Yeah, V out is 2 volt. So your Vg1 minus Vi1 equals to 2 volt, which is greater than Vtn. So Vg2 is equals to Vi1 equals to 1 volt. Vi2 minus Vg2 is equals to 1 volt, which is greater than Vtp. So V0 is equals to 2 volt. Okay, moving to the C part. If Vi1 is equals to 2.7 volt and Vi2 is equals to 0 volt. No, VG2 is not 0 volt. No, VG2 is not 0 volt.
Ma'am, here the VGS value is coming as 0.3, so it will be less than the threshold voltage, that is 0.5.
Yeah.
So that means the transistor is not, that means the NMOS is not in on state, it is in cutoff because the value is less. So then I think the value of VG2 will be equal to VDD, that is 3 volt.
No, it will be 2.5 volt. There will be a subtraction of the threshold as well.
Threshold. Ma'am, V out is 0 volt.
No. Okay, so I'll do it. So VG1 minus Vi1 is equals to 0.3 volt. So this is VTN. So VG2 is equals to VG1 minus VTN, which is equals to 2.5 volt. Now Vi2 minus VG2, which is minus 2.5 volt, is less than VTP. So VG2 plus VTP is equals to 2.9 volt. Okay, so moving on to the next question. Uh, you have to calculate V out. Assume Vg equals to 2 volt and Vtn is equals to 0.7 volt. So what is if Vi is equals to 0.5 volt?
zero point 0.5 volt.
Yeah.
Point 0.5 volt, ma'am.
Yeah. So Vg minus Vi is equals to 1.5, which is greater than Vtn. So V out is equals to Vi is equals to 0.5 volt. Okay, so when Vi is equals to 2.5 volt,
1.8 volt.
no,
2.5 volt, ma'am.
no, yeah, 1.3 volt. So Vg minus Vtn. Okay, so if now this is the same for PFET, initially Vg is 0 volt and VTP is equals to minus 0.6 volt. So what is the output when Vi is equals to 0.3 volt?
Zero point
Point
three
0.6 volt.
volt.
What turn by turn, please?
0.6.
Yeah, 0.6. Saurav, what is your answer?
0.6, ma'am.
Yeah. So V naught is equals to 0.6 volt. Yeah. So now if Vi is equals to 3 volt, what is the value of V output?
3 volt.
Yeah, it is 3 volt. Okay. Find the midpoint voltage Vx and output voltage V naught for the chain of two NMOS transistors, assume VDD is equals to 1 volt and VTN is equals to 0.5 volt. So when your Vi is equals to 0 volt.
And both are 0 volt.
Yeah. So VDD minus Vi is equals to 1 volt, which is greater than VTN. So your Vx is equals to 0 volt and your VDD minus Vx is equals to 1 volt, which is also greater than VTN. So basically both are kind of short. So your V out is equals to 0 volt. Okay. So if Vi is equals to 1 volt,
Both will be 0.5 volt.
yeah, both will be 0.5 volt. I'll wait for
0.5.
others to complete.
0.5 volt, ma'am.
Yeah, 0.
Vx and Vout. Because the value is less than the VT threshold value.
Yeah. So VDD minus Vi. So Vx is equals to 0.5 volt. 0.5 is to VTN. So Vx is equals to V out is equals to 0.5 volt. Okay, so you have to tell me the number of NFET and PFET that are used. Number of NFET and PFET used for implementing F is equals to X plus Y plus Z into Y whole bar.
Four N MOSFET and four P MOSFET.
No.
Using CMOS logic, we have to design it or what?
Yeah, using CMOS logic.
Ma'am, for plus operation, the transistor, the NMOS should be in parallel and the PMOS should be in series, I think.
No, I'm just asking number of transistors.
Okay. Ma'am, total 8 number of transistors.
No. Okay, so
And
using
3
Boolean,
NMOS, 3 PMOS.
no. So this will be x, y plus y, z bar, your function. So x plus y, 1 plus z. So this will be x plus y. So only 2 NMOS and 2 PMOS will be used. Okay, so with this we end up today's session. So if you have any doubt, so you can ask. Okay then. See you next week.